Hey guys, in this video we are going to be talking about going in between logs and exponential, creating exponential equations, and then solving them. This is for our quiz tomorrow. So we're going to go through this review tomorrow before we go to lunch, and then after lunch we're going to take a quiz very similar to this review. So first we're going to look at when we're given exponential form, going to log form. So let's switch this so we have more room to write. So we're going to take our base of our exponent, and that is going to be our base of our log. Then that 512 is what we're taking the log of. And then we're going to make it equal to our 3. For number 2, we're given exponential form. We're going to our log form. So our 6 is our base of our exponent, so it's going to be at the base of our log. The number we're taking the log of is that 7,776, and we're going to set it equal to 5. And 1 through 4, this is all we're doing. We are not solving for anything because there's not an X or an A or a letter for us to solve for. So we've got base exponent is 7, so that's going to be the base of our log. The number we're taking the log of is 16,807, and we're going to make it equal to our exponent, which was 5. And number 4, again, base of our exponent is our base of our log. We're taking the log of what it was equal to, so 9,683, and we're setting it equal to 9. So there are some examples of taking exponential form and turning it into a log form. Then we've got to start with our log forms and change it into exponential form. So same thing to kind of remember is that whatever the base is going to stay our base. So our base of our log is 9, so the base of our exponent is going to be 9. We're going to raise that 9 to the exponent, or the power of 5, and then we're going to make it equal to whatever we took the log of. So 59,049, and there's our exponential form. 6, again, same thing. Make sure you realize the 8 is our base, so it's also going to be our base of our exponent. Our power, or our exponent, is going to be 3. We're going to set it equal to 512. There is nothing else we can do. There is no letter to solve for. For 7, our base is 15, so that is the first thing we're going to write. Raise it to our 3 and make it equal to the value that we took the log of, which was 3,375. And 8, again, base is the first thing we do, so 6. Whatever it was equal to, which was 4, is in our exponent, and then we're going to make it equal to whatever's left, which was 1,296. And there's the examples of taking our log form and turning it into our exponential forms. Now, 9 through 14, we are having to solve for something. That x is there, so we have to figure out what x equals. So this is where Desmos is going to come in handy. So we're first going to take this exponential form and change it into a log form. So our base of our exponent is 6. What it's equal to is that 1046. So we have log base 6 taking 1046. And we're going to make it equal to the exponent, just like we were doing, which is 4x. Now we still can't figure out what x is because x is not by itself. So before we put anything in Desmos or our calculators, we're going to get x by itself. So there's multiplication in between this 4 and this x. So we're going to divide by 4 and divide by 4. So now we can put it in our calculators or in Desmos. How we're going to put this in Desmos is we're going to put a parentheses. We're going to have log. We're going to have x in our base. And we're going to type out that 1046. But how Desmos puts it is that there's another set of parentheses around the value you're taking your log of. The reason why we have these extra parentheses around our numerator is so our calculators or Desmos does not get confused of what we want to divide 4 by. We want to divide the whole log by 4, not just the 1046. So now we're going to review how to put this in Desmos. So we're going to put our parentheses. We're going to go to our functions. We're going to go to this MISC and use the log A. The log A versus just the log, it gives us the option of putting a base that is not just 10, because remember 10 is understood. So this way we can put our 6, then we can put our 1046, and then we're going to go outside our parentheses and do our division of 4. And that is giving us our answer, and we're going to round it to the second decimal place. So we're getting 0.97, and that is how you would answer number 9. So number 10. Number 10 is a little bit more difficult. In this problem, we do not just have our base of our exponent on the left side of our equal sign. So we want to get rid of this multiply by 2. That doesn't need to be there, so we need to get rid of it. There's multiplication, so we're going to divide by 2. Divide by 2. Remember, what we do on one side, we have to do to the other. So 2 divided by 2 is 1, so it cancels out. So we're left with 3 raised to the 3x equals 6,533 divided by 2 gives us 3,266.5. Now number 10 looks like we're used to. We're going to take our 3, which is our base of our exponent, and put it in our base of our log. And then we're going to take the log of that 3,266.5, and then we're going to set it equal to our exponent, which is 3x. Now, kind of like number 9, x is still not by itself, so we're not done. So we've got to get rid of that multiplication and that 3. Multiplication's in between. So we're going to divide by 3, divide by 3. Again, we want to put a parentheses around our numerators so our Desmos or our calculator is not confused of what we want it to calculate. So we're going to put it in Desmos. We'll put in this in Desmos. So we're going to exit out of what we had in Desmos by hitting the X button. And we've got parentheses, functions. We got to go find our log A. We've got 3 in the base. In the parentheses, we've got 3266.5. On the outside of everything on the numerator, we have divide by 3. So once we do that, we have it 2.455, so on and so forth. So we're simply going to put for our answer 2.455. Now, I've told you multiple times, but I'll tell you again as a reminder, I'm okay with whatever decimal place you want to round to as long as it's not a whole number. So for number 10, you could have put 2.5. You could have put 2.46, or exactly what I had put. You could have not just round to a whole number and just put 2. That would have not been acceptable. As long as you round to a decimal place, I'm okay with it. Alright, number 11. Same thing, our base of our exponent is not by itself on the side of the equal sign. So we've got to get rid of everything else. So we're going to get rid of this positive 3. Because it's positive, we're going to subtract 3 from both sides. 3 minus 3 is 0, so it goes away. And then we're left with 4 raised to the x plus 7 equals our 35 minus 3 is 32. Now it looks like what we're used to. Our 4 is our base, so we've got log base 4, taking 32. We're going to set it equal to our exponent, x plus 7. X is not by itself, so we're going to subtract 7 from both sides. So we're going to have parentheses log 4 of 32. Subtract 7 equals our x. Now we cannot combine at 32 and 7 because it's kind of like terms. That log base 4 is attached to the 32. It is not going to be attached to this negative 7 or the subtract 7. That is why we cannot combine them. So we're going to put it into Desmos just like that. So exit out. You can either push the exit right beside it or push the little arrow with the X down here at the bottom right corner and just mark or delete everything. So we've got parentheses, our log A with a base of 4. In our parentheses, we're taking 32, log of 32. Then outside of it, we are subtracting 7. And that is giving our perfect decimal of negative 4.5. Negative 4.5 would be our answer for number 11. Again, please do not round that number to negative 5. Right, number 12. Number 12, it does look like what we're used to. It has nothing extra. We just have our base to deal with. So we're going to take log base 8 of negative 16 equals our exponent, which is 4x plus 2. Now we're going to ignore our log or our left side of our equation for a second and focus on our right side. We want our x by itself. So we got to get rid of the positive 2. So So to get rid of it, we got to do subtract 2, inverse operation, subtract 2. 2 minus 2 is 0, so it cancels out. So we're left with log base 8 minus 16 minus 2 equals 4x. X is still not by itself, so we got to get rid of it. So we've got to divide by 4 because there's multiplication, so inverse operation. And what we do on one side, we've got to do to the other. So we're left with, on the left side, log base 8 of negative 16, subtract 2, divide by 4. So that is what we're going to put into our calculator. So we're going to exit out. We've got parentheses, then another parentheses, log A. 8 is our base. Inside we've got negative 16. Now, not outside of all of the parentheses, but outside of the log parentheses, we've got subtract 2. And then we're going to divide the whole thing by 4. Now, I don't think we went over an example in class, but because I know that we solved number 12 correctly, we are simply going to put our answer as undefined. So 12, we would put x equals undefined, or UND. Alright, 13. 13, our base is not by itself. So we've got to get rid of this positive 9. This positive 9 can be taken out by negative 9. So 9 minus 9 is 0. So that's how I know it cancels out. I'm left with 6 raised to the 2x equals 68 subtract 9 is 59. Now we have our base of our exponent, so it's going to be our base of our log. We're taking the log of 59 equals our exponent, which was 2x. X is not by itself, so we're going to take it out. Take the 2 away, so divide by 2, divide by 2. So we have log base 6 of 59 divided by 2 as our x. So x equals, we're going to use our Desmos, exit out of what we had in there, parentheses, log A of 6, 59 is what we're taking the log of, and we're dividing by 2. So we get 1.137858, so on and so forth. So again, you can choose it to round it to any decimal place, but on my answer key, I'm always going to have extra decimals, so you can check your rounding. So that would be our answer for number 13. Still do not have our base by itself, so we cannot simply just go to our log form. We've got to get rid of our multiplied by 4, so we're going to divide by 4, divide by 4. 4 divided by 4 is 1, so it cancels out. So we're left with 3 raised to the 2x minus 3 equals 68 divided by 4, simplifies to 16. Now we have our base by itself, so we have our log base 3 of 16 equals our exponent, which was 2x minus 3. X is not by itself, so we're going to add our 3, So negative 3 plus 3 is 0, so it cancels out. So we're left with log base 3 of 16 plus 3 equals 2x. X is still not by itself. There's multiplication in between the 2 and the x. So we're going to divide by 2 and divide the whole left side by 2. 2 divided by 2 is 1, so it cancels out. So we're going to put this whole thing in Desmos to get our answer. So we'll have x equals, let's go put that in Desmos. So I have parentheses, and then another parentheses just for our log. So the first parentheses I put up there was for our whole numerator. Then the second set of parentheses I clicked was for our log only. So our base is 3. We're taking the log of 16. And we have plus 3. Then we're taking this whole numerator that is within a parentheses. We're going to divide it by our 2. So we get 2.76, so on and so forth. For space, I am simply going to put 2.76. So there is number 14. So then we go on to our word problems. So our word problems. First off, if you do have it printed in front of you, you are canceling out one of these nuns. I don't know what happened, but somebody got happy with the nuns. So we're given this equation and we are asked, what is the rate of growth or decay? Well, first question, even if it didn't ask, is it growth or decay? The 0.94 is telling us about our growth and our decay rate / factor. So because our factor is less than 1, we're going to be looking at it at a decay equation. Now when we talk about a decay equation, within our parentheses or our base of our exponent, we are looking at 1 minus our rate is going to give us our 0.94. What I like to ask everybody in the class is, if we got $1, we want to subtract some amount of cents, and I want to get 94 cents out of it. How many cents do I have to subtract from $1? Well, $1 is 100. 100 to 94 is 6. So I've got to take 0.06 or 6 cents away from the dollar to get that R. And that is how that 94 came about. Because if you were given 6%, you would change it to 0.06 and you would subtract it from 1 to get that 0.94. So the answer is, what is the rate of growth or decay? It is turning the 0.06 into percent, so it is 6%. Question B. Question B asks, when will the value of the car be 8,000? So again, we already talked about decay. Typically a value of a car always goes down, not up. We are going to set our y equal to 8,000 because that's the end result after it's decayed. So we've got our 8,000. We're going to make it equal to our equation that was given. So our 35,999. Our decay factor of 94, and raise it to our x. So we're looking for our x value. That is when the value will be, or how long it will take for our car to be $8,000. So there's multiplication in between the 35,999 and our decay factor. We've got to get rid of it because the only thing that is our base of our exponent is the 0.94, not the whole right side. So we're going to get rid of that 35,999 by dividing. A number divided by itself is 1, so it goes away. And then I'm going to simplify the right side, and I get, I'm actually not going to simplify it because it creates a ugly decimal, so I'm just going to keep it as is. So 8,000, because it just creates a number. So don't let this fraction freak you out. Put a parentheses around it and just treat it like any other number. So left on our right side is 0.94 raised to our x. Now if I flip it, it will look just like what we've been used to. So if I had 0.94x equals that big fraction, 8,000 over 35,999. Now I've got my base. I've got what I'm going to take the log of. So log 0.94. I'm going to take the log of 8,000 divided by 35,999. I'm going to set it equal to my x. So now I'm going to put this lovely log into Desmos. So I'm going to Desmos. I'm going to exit out of everything that I've got in there already. So I've got log A, because I want to put 0.94 in my base. And then I'm going to have 8,000 divided by 35,999. So that gives me 24.3 years. So that would be our work and our answers for 15. For 16. 16, we're thankfully already given our equation. So we've just got to answer some questions about it. Same thing that we did with 15. We're looking at our factor, which is 1.12. It is above or greater than 1, so it is going to be growth. Our starting value is going to keep growing. By the way, if you forgot, our starting value is 8,000. We're talking about population of a small town in Utah. So because we're talking about population, can we have part of a human? And don't overthink it. Don't say, oh, well, if it's a baby, it's half of a human. No, it's still one human. We're not going to be in a zombie apocalypse or whatever. We're going to have one whole human, no decimals. So now we're asked, what is the rate of growth or decay? So we're taking our 1 plus whatever our rate is, and we're having plus because it's growth, and it's going to give us our 1.12. Kind of like our decay, we can ask ourselves, okay, we start with $1, we're adding some amount of cents, and we're going to get $1.12 back. Well, how many cents did we have to add? We had to add 12 cents. So our 12 cents changed, or our 0.12 changed into percent is 12%. Now, if you don't need to write it out as 1 plus R and ask yourself about the money, that is perfectly fine. If you can look at that 1.12 from the problem and say it's 12%, that's perfectly fine with me. So then we go on to B. B asks, when will the town's population reach 9,000? So 9,000 is going to go where this P of T is in our equation given. So that's going to be the end result. 9,000 equals our 8,000. Remembering between the 8,000 and the 1.12, there's multiplication. Then our T is in our exponent. So we're going to get rid of that 8,000 because we want the base of our exponent to be by itself, and it's not yet. So we got to divide by 8,000, divide by 8,000. So when we do this, we have 8,000 divided by 8,000, which cancels out. And we're left with, on the left side, 1.125 equals 1.12t. Now, if you can solve it from here, changing it to our log form, that is fine. But I'm going to keep on switching it so it looks like we're used to it. Again, I'm switching it so our base and our exponent is on our left side versus our right side. It means the exact same thing. So our 1.112 is our base. Then we're taking the log of our 1.125 and we're setting it equal to t. So this is what we're putting into Desmos. We're going to exit out what we have. Function log A. We've got 1.12 in our parentheses, 1.125, and there's our answer. We've got 1.039, so on and so forth. So this question is talking about when will the town's population reach. So this one's not talking about people, it's talking about years. So we can't have decimals when we're talking about years. So our answer, it's going to be, what I'm going to put on mine is 1.0393 years. So there's your answers for 16. Then lastly, 17 is the only one we're having to create our own equation. It's not given for us. So we first have to acknowledge that this word depreciates means decay. So we're going to have to be going decay. Our 7% is what's given, and it's going to be our rate, not our factor. So our rate is going to be found in the parentheses. It's going to be 1 plus or minus r, and that is what we're going to put as our factor. Then we're told a consumer purchased a car in 2005 for $19,000. So this is going to be our A. This is going to be our initial amount. So let's write a function for it. So we always have y equals our A, and by the way, before I even do that, if you need it, our general form for our exponential is y equals A times B, which is our growth or decay factor, times our x. So y equals our A, which is 9,000. Parentheses, well, because we have our decay, we're not going to be using this plus sign. We're going to be using the subtraction. So 1 minus our 7%. Well, we don't put 7% in there. We change it to a decimal, which is 0.07. So we put it in our parentheses. And then we raise it to our x. Now, I would be perfectly okay if you would keep it just like that, or you can simplify it. So you have y equals still our 19,000 as our initial amount, but you go ahead and subtract that 7 cents from $1. That's all that is. So it would be 0.7 or 93 raised to the x. So that would be our function to model the situation. So then question B asks, when will the value of the car be half of the purchase price? So we're going to take our starting value, which was at 19,000. We're going to take half of it. So we're going to take it 19,000 and divide it by 2. And we get 9,500. So we're asking, when will the end result of the function be 9,500? So we're setting up our equation. 9,500 equals our initial amount times our 0.93x. Again, our base is not by itself, so we got to get that multiplication and that 19,000 away from our base. Divide by 19,000. Divide by 19,000 on the other side. A number divided by itself cancels out. And then you're left with that 9,500 divided by 19,000, and that simplifies to 0.5 equals our base on our right side was 0.93x. And then we can create our log. Again, I like to switch my order, so it's always the first thing I see that I am taking the base of. So 0.93 is my base of my exponent, so it's the same base as my log. Now I'm taking a 0.5 log and setting it equal to x. So I'm putting that log base 0.93 of 0.5, and it's going to give me a value. So I'm going to go back to Desmos. I'm going to find my log A. My base is 0.93. Inside the parentheses, I have 0.5. So that's giving me 9.55. So that is the years. That is how long it will take. 0.955 years. And there are your answers for 17. So again, tomorrow we will go over this step by step, and then after lunch we will take a quiz, nudge nudge, hint hint, that looks just like this. See you guys tomorrow.